morning, sixth graders. Today we are going to spend some time talking about the properties of equality. And pretty much what those mean is just that when we have an equation, so let's say for example that we have 4 plus 8 equals 12. When we have an equation, both sides of the equal sign need to be the same. So we know that 4 plus 8 equals 12. So if we were going to solve this problem, we would have 12 equals 12. And we know that that's true. If we had, for example, 4 plus 8 equals 12, and then let's say on this other side, I decided to add 3, now all of a sudden we know that these two sides of our equal sign are not equal to each other. So what we would need to do, because we know that this right here is 12, in order for both of these to be the same, we would have to add 3 to this side so that both sides of our equal sign can end up to be the same value. So we're going to talk about some different properties of equality today when we are working with equations. So the first property of equality is the addition property of equality, and that's what we just worked with up here. So the addition property of equality says that both sides of an equation stay the same when the same amount is added to each side. Okay, so for example, kind of like what we just did, if we had the equation 5 plus 3 is equal to 8, if I were to rewrite this same equation and say 5 plus 3 minus 2 is equal to 8, all of a sudden this is not true. Since this part is the same and this part is the same, in order to make this side right here of my equation true, I need to also subtract 2 from the right side of my equation. And I should end up with the same answer on both sides. So now instead of having that 5 plus 3 equals 8, we have 5 plus 3 minus 2 equals, oh, I'm so sorry, that's supposed to be plus 2. Plus 2. For addition, it works the same way. So we've got 5 plus 3 plus 2 equals 8 plus 2. And now instead of having 5 plus 3 equals 8, we should end up with 10 equals 10. So kind of along the same lines for the subtraction property of equality, the definition is almost exactly the same, except instead of saying when the same amount is added to each side, we're going to say both sides of an equation stay the same when the same amount is subtracted from each side. Okay, so using the same equation from up here, and this time it'll actually be right when I'm subtracting it. If we have 5 plus 3 equals 8, and then I change it to be, oh my gosh, I'm having some trouble this morning. Let's say, let's make that a 3. 5 plus 3 equals 8. If I change it to be 5 plus 3 minus 2, then I also have to change this side to be 8 minus 2. because this part is equal to 8, and we've got the minus 2, so now we would have that 6 equals 6, which is true. Right? And then for the other properties of equality, we also have the multiplication property and the division property of equality. And just like earlier, the definitions are pretty similar. Both sides of an equation stay the same when the same amount is multiplied on each side. Okay, so to use the same equation that we've been working with, we have that 5 plus 3 equals 8. If I were to, I'm going to put it in parentheses so that way we can do order of operations when we're solving it. But if I take the quantity 5 plus 3 times 2, then that means on this side, since this equals 8, in order to make my two sides the same, I have to also take my 8 times 2 so that I can show that 16 equals 16. Okay, and then last but not least, we've got our division property of equality, which you'll probably be able to tell the definition by now, but both sides of an equation stay the same when each side is divided by the same amount. Okay, so with that same equation that we were working with earlier, we have that 5 plus 3 equals 8. If I was to divide now, the quantity 5 plus 3 divided by 2 equals 8. Since this part, 5 plus 3 equals 8, in order for both of these sides to be the same, I also have to take 8 divided by 2, and I should have that 4 equals 4. Now, we have been working with variables lately in our expressions, and so I also wanted to show that the same properties of equality hold true when we are working with variables. So let me show you some examples with variables. If we had the equation 5m plus 4 equals 19, and then let's say that on my right side, I changed my equation to be 19 plus 3. This part tells me 5m plus 4 is equal to 19. So now all of a sudden, if I add this plus 3 on this side, in order to make the left side of my equation true, then I also have to add 3 to the left side so that my equations will be equal to each other. For subtraction, if I had 5b minus 6 equals 14, and I changed the right side of my equation to be 14 minus 2, whatever I do to the left side, I'm going to have to, or sorry, whatever I do to the right side, I have to do it to the left side. So I'm going to change it to be 5b minus 6 minus 2, because this part is equal to this part, so that means I have to do minus 2 to keep both sides of my equation true. For a multiplication example, I have 3x plus 1 equals 7. If I were to change the right side of my equation to be 7 plus 2, I'm going to, 7 times 2. I'm going to group this in parentheses so that we can do order of operations, but then I also have to take the left side of my equation, times 2. And then for division, if I had 3 times t was equal to 24, then that would mean if I change it to be 24 divided by 4, then I would have to also do the left side to be 3t divided by 4. Okay? So no matter which property of equality we're using, what we need to remember is that in order to keep both sides of an equation the same, you have to do the same operation to each side of your equation, whether it be addition, subtraction, multiplication, or division. Okay? If you have any questions, send a message to your teacher, or if you're in class, raise your hand, and have a great Monday.